One of the heaviest used design pattern nowadays, if I talk about uh, Python, then it is iterator design. And based upon the iterator, then we have a generator also and loosely comprehension also. So nowadays, iterator is kind of hotcake in design pattern. So we'll talk about iterator design pattern, and in the similar design pattern, in similar design pattern, we'll talk about iterator design pattern and iterator design pattern and adapter design pattern and iterator design. So iterator design pattern, first why we need iterator design pattern. Okay. Now suppose like I have I am using a television, and now in the kind of television set itself, or I have a remote control and I want to see channels, and I don't know how many television I would because I am in a hotel room and then I have a remote. So if I go hotel to hotel, TV changes, and then how I know that kind of which is the key for the for a particular channel. So if it is written in Chinese or Japanese or German, so it is kind of cumbersome. Means no one can use it. So iterated design pattern works in a fashion where few things that is common everywhere. Like there is a symbol called next, 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 previous, or like that. If that pattern is also there, I can switch on the television and I can start going to next channel. So that is iterator. Means I iterate through the list in the TV through generic fashion. Okay, so that is a good example for the iterated design pattern. Means the when we iterate through a list, the protocols what we follow should be common among everywhere I am iterating. So this falls under generic algorithm in C++, iterated design pattern. Now, kind of how it is useful in C++ in the sense that I have a kind of a list. I have a class which has a array kind of data structure like map or set, or I have list or tuple or string itself. So if I want to iterate kind of these data structures, these memory data structures, then they all have different set of functions. One is saying if I need to kind of go to next, someone would say next, someone would say forward, someone would say this, that. If I need to kind of push something, then someone would say push, someone would say insert. So if there are so many kind of data structures available, then and they maintain list kind of sequence kind of data structure, then if I want to use their functions to kind of manage the sequence, either to insert or to browse through, then I have to follow the interface what they provide. Okay, so every every sequence type may have a different kind of interfaces, so that is something that cumbersome to use. Now iterated design pattern comes to save us, like if there is a class that is a sequence class, and if this is a sequence class, then can I have an iterator which has a set of functions that is generic, like next, 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 previous, then insert, and okay, like this. So now so this is a sequence data structure of list. This is map, this is set, this is hash, multi-hash, and so many. Now but iterator, okay, now iterator is only one. This is what we want, that iterator should be only one. Whatever the method, whatever the I can say template method. Whatever methods the iterator provides, that's it. It depends, it doesn't worry. I am not worried that this side. So iterator behind the scene, okay, it iterates a particular sequence. Okay, if it iterates particular sequence, then internally it knows that how a sequence can be iterated or it can be manipulated. But iterator provides the set of template method that is generic. So this is something that is a kind of you can say that breathtaking. Means I have 20 kind of sequences, and then I need to manipulate them, and everywhere I go and read about the documentation of functions, and if again new 21 new comes, then it becomes impossible. So in this kind of scenario, iterator generic functions which are not going to change, always it will be available. It really gives kind of respite. So that is helpful. Now, how iterator I would implement? When iterator, when iterator has a set of functions, but iterator would iterate the, so if I have a list class, inside the list class, I have actual list, that is linked list or whatever. So the actual data structure which keeps the data, that is a member variable inside the list. Same as map set whatever. So that is a wrapper class. Inside that actual C data structure that lives in, or C++ data. So the iterator and the data class or the sequence class. So iterator, so this class should consider this class, iterator class, as friend, so that it can go and touch the private code also. This is one scenario. So iterator when it is iterating a particular class, so it should touch all the private members also. This is one scenario. Second scenario is that in iterator I cannot do if def. If it is a list, then do push or do get. If it is a map, then insert or get back, get front, push back, put front, okay, peek. So this many program I cannot write in the iterator class itself, because this doesn't follow the basic design principle, open for extensibility and okay, close for any modification. So we are keep on modifying if iterator is supporting more sequences. So now iterator will create as an interface itself, where it has set of functions, and from there the derived type, whatever is deriving from the iterator, are the concrete objects. So the iterator interface is realized through, now we have map iterator, list iterator, but all the concrete class, they would work through iterator abstract pointer only. So we can pass a iterator abstract pointer everywhere as a function parameter or whatsoever. Now any object that is realizing the iterator pointer, against that we can call the template method that is available in iterator class itself. So doesn't matter, I am using list iterator, map iterator, or set iterator, multi-hash iterator, whatsoever. The function that is available in iterator class, those functions only I need to worry. So if I am habituated of using iterator interface class, doesn't matter. Only thing I need to know, what is the sequence. According to sequence, I would instantiate the iterator realization class that is realizing the iterator interface. That's it. So I have a data class as list, tuple, set, multi-set, multi-hash, okay, map, like that, so many. And like now I have a iterator interface class. There I have push, pop, next, previous, and from the iterator I derive the concrete classes as set iterator, multi-set iterator, hash, multi-set, hash, list, tuple, map, string, and whatever. Now if new int sequence comes, Inside the sequence, I'll set iterator as friend class and then I'll do my work. Now, since iterator is friend class, interface would work as a friend, and in the iterator I am drawing, so there is a new class called XYZ. Now, from the iterator I will have a derived class XYZ iterator, that's it. And XYZ added iterator would conform to the template method, that means it would fill the template method that is provided in the iterator design iterator class, and then someone would just instantiate XYZ iterator, and then he should use the way he was using all the iterators. So this is something that is excellent in iterator design pattern. So iterator design pattern is for people who want interface what they want. Means they want certain kind of interface to be worked with everywhere. So now they have iterator in their mind. That's it. So like they have seen a generic TV remote, and that's it. Like any Android phone, someone would work because uh, any company, because the basic interfaces are same. Like that, television, the remote basic functionalities are same, graphics is there next. Now anyone can use any company remote because they conform to the iterator design pattern. So that is about it. So whatever client wants, that interface comes through iterator, and behind the scene, iterator does the the complex thing or change of interface. So these classes, these are the sequence classes, data class. They provide their own interface. Iterator provide their own interface, and internally iterator which contains kind of these sequences, and it manipulates the operations. So it is something like a delegation loosely. So whatever someone is calling, then internally loosely, okay, it delegates those calls, and or it does some manipulation or changes the interface what iterator is providing to the interface of the sequences. Is it not the same as adapter design pattern? Adapter design pattern, client want a particular interface. Okay, like we have many times we have shown adapter design pattern where kind of like this is okay. So this is a kind of a remote mic, and if I see the charging, if I see the charging, it is type C charging. Okay, now I can charge, but the power cable what I have, it is completely 220 volts. So here the interface is what client wants, and okay, so interface is what a client wants, and and the this get charged through another USB. That USB finally hooks up to kind of another adapter. Adapter hooks up to 220 volt. So everywhere there is change in interface. So interface, this is a Type C interface, and it goes to USB Type A, I believe, and then to adapter, and then to 220 volt power. That is a 50 hertz. So this may be another hertz. So everywhere we have adapter design pattern. So adapter design pattern, whatever client wants, that interface has to be provided. Behind the scene, those interfaces need to be changed to the interface where it is hooked in. So one side and other side. So one side another interface, one side another interface, and whatever the client wants, that interface is getting modified to the interface it is connected to. This is adapter design. But in adapter design pattern, there is inheritance. Okay. Whereas in the iterator design pattern, there is containment. So iterator contains the sequences. Okay. Whereas in adapter design pattern, the adapter inherits privately from a available interface. So available interface from there, like it is changing the type A to type C. So available interface, okay. So available interface, it is from there it derives privately and it provides the interface what client wants. Okay, and adapter design pattern falls in structural design pattern because it is a structured changing the structure, where iterated design pattern, it provides a behavior kind of thing. It looks like it is providing a behavior kind of thing. So it falls under behavioral design. So behavioral design pattern is iterated design pattern, where a structural design pattern is adapter design pattern. Okay, but but the scenario is little similar. They change the ready-made interface to the interface what client wants. So amazing and nice to use iterator. So in Python, the class which support iterator, they implement a special attribute that is underscore underscore iter underscore underscore, and that returns the iterator class. And iterator class must have underscore underscore next underscore, which will be called against the iterator. So there it can iterate the list. So if I call a class in a for loop, it expects the iterator, and in the iterator it calls the next. And then in Python, it will start browsing the iterator class next function and again and again. Same is used, similar is used by generator function also, little bit comprehensive. So iterator is used everywhere. So please don't use any sequence type directly to iterate anything. Please must use iterator design pattern. Okay, please use adapter design.